Welcome to another episode of Astronomy Daily. I'm Steve, your host. It's the 4th of November, 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Oh, and another big episode looking at the objects discovered in the Kuiper Belt, giant unrolling space telescopes. Yes, you heard me right. Also, the return of Chinese astronauts from their space station and an update on Expedition 72 gearing up for a trip to the ISS, all from the Astronomy Daily newsletter. And joining me, as per usual, is my AI pal who's fun to be with. G'day, Hallie. What's happening?
Hi there, my favorite human. It's all happening, of course.
Oh, really?
Really, everywhere, all the time.
Oh, you're referring to the jumble of stories we've got today.
That's just a few bits and pieces from the Astronomy Daily newsletter, too.
Well, as you say, there's something new every day, and I don't want to miss a thing.
I know, it's all happening all right.
Well, Hallie, tell me, what's your favourite story this week?
It's the same as yours.
Okay, which one?
The meteors, which are due across November.
Oh, of course.
I love to see them every time, just like you.
And you've got that story, haven't you?
I'll have that story shortly.
Rightio, so we should launch into it. Why don't you take the lead, Hallie?
Okie dokie, human. Wait.
What's up?
Did you say giant unrolling space telescopes in the intro?
Well, yes, I did say that, Hallie.
Crikey, sounds amazing.
Crikey indeed. All right, how about you head into the news, Hallie?
So pushy. Here we go. For Expedition 72, crew members are gearing up for a brief ride to relocate the International Space Station's Dragon Freedom spacecraft this weekend, creating space for an upcoming cargo mission. The crew has also spent the week conducting life science research and performing maintenance tasks aboard the orbiting laboratory. NASA astronaut Nick Hague and Roscosmos cosmonaut Alexander Gorbanov reviewed relocation procedures on Friday for the Dragon Freedom's upcoming maneuver. The relocation is scheduled to begin at 6:35 a.m. Eastern Standard Time on Sunday when Freedom undocks from the Harmony module's forward port. The crew will include Commander Suni Williams and flight engineer Butch Wilmore, joining Hague and Gorbanov for the relocation. The spacecraft will be redocked to Harmony's space-facing port at 7:18 a.m. Hague and Gorbanov initially arrived at the space station aboard Dragon Freedom as part of SpaceX Crew 9 on September 28. Their return to Earth is planned for February, along with Williams and Wilmore. The relocation of Dragon Freedom will free up the forward Harmony port for the arrival of a new Dragon cargo mission, which is set to launch from Kennedy Space Center at 9:29 p.m. on Monday. The cargo Dragon is expected to dock at 10:15 a.m. on Tuesday, bringing nearly 6,000 pounds of science experiments and supplies for the station. Hague and Wilmore will oversee the arrival of the cargo Dragon. Flight engineer Don Pettit will assist with Sunday's relocation, monitoring Dragon Freedom's automated movements from within the station. He joined his crewmates at the end of Friday's shift to coordinate with mission controllers regarding the procedure. Earlier in the day, Pettit and Hague worked together to collect blood samples, spin them in a centrifuge, and store them in a science freezer for later analysis. Pettit also spent time dismantling parts of the cell biology experiment facility in preparation for the new experiments being delivered on the next cargo Dragon. Hague continued reviewing the procedure for commanding Dragon during its relocation maneuver on Sunday. Meanwhile, Commander Williams and flight engineer Wilmore were focused on station upkeep, including replacing filters on the Tranquility module's water recycling system and installing a new instrumentation box on the Advanced Resistive Exercise device. The duo also took time to train for the upcoming cargo Dragon mission. In the Russian segment of the station, flight engineer Ivan Vanner assisted Alexei Ovchinin with maintenance tasks in the aft section of the Zvezda service module. Ovchinin spent part of his day studying piloting techniques for future planetary missions, while Gorbanov concluded an experiment observing Earth's atmosphere in ultraviolet wavelengths before resuming relocation preparations with Hague. The southern torids will reach their zenith early Tuesday morning and the northern torids on November 12. While the two showers only produce around 5 visible meteors per hour under ideal viewing conditions, they are often very bright fireballs, said Sally Brummel, planetarium manager at the University of Minnesota's Bell Museum. What's notable is that they're likely to produce brighter and longer-lasting meteors than some other showers, even if there aren't as many at a time, she said. The southern torids will peak on an evening with only a slim crescent moon just 11% full. The northern torids may be more obstructed by moonlight since the moon will be 79% full. Viewing of both showers will last into December. Not long after the Taurids, the next big meteor shower, the Leonids, will peak on the early morning of November 17th. A 3-person Chinese crew returned to Earth early Monday after more than 6 months aboard the Tiangong space station, state news agency Xinhua reported. Yi Guangfu, Li Tsong and Li Guangsu were all in good health after touching down in the return capsule of their Shenzhou spaceship at the Dongfeng landing site in Inner Mongolia, Xinhua said. The 3 men had traveled to Tiangong in late April and were met on October 30th by 3 new astronauts, including the country's only woman spaceflight engineer, with whom they did a 5-day handover before making their return journey. China has ramped up plans to achieve its space dream under President Xi Jinping. Its space program was the third to put humans in orbit and has also landed robotic rovers on Mars and the Moon. Crewed by teams of 3 astronauts that are rotated every 3 to 6 months, the Tiangong space station is the program's crown jewel. Its core module was launched in 2021, and it is planned to be used for about 10 years. Beijing says it is on track to send a crewed mission to the Moon by 2030, where it intends to construct a base on the lunar surface. Now it's back to you, my favorite human, and to tell you the truth, I just want to hear about the giant unrolling space telescopes.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
Oh, one of my favourite things about astronomy and space is the Kuiper Belt and the Oort cloud, the region beyond Neptune, where, well, poor old Pluto is one of the most popular or well-known objects out there. The Subaru telescope has discovered new objects beyond the known Kuiper Belt, suggesting a more complex structure at the edge of our solar system. This finding could reshape our understanding of planet formation and boost the, well, search for life outside Earth. Using the Subaru telescope to observe the outer solar system, astronomers have uncovered new objects in the regions where none were previously expected. These newly found bodies likely belong to a much larger yet to be discovered population. This finding has significant implications for our understanding of the solar system structure and history. Most notably, it suggests that the solar system may share more similarities with other planetary systems than previously thought, which could influence the ongoing search for life beyond the solar system. The Subaru telescope has been conducting observations of the outer solar system to help support NASA's New Horizons spacecraft, the first mission to observe the Kuiper Belt on the outer edge of the solar system beyond Neptune while flying through it. Dr. Fumi Yoshida, University of Occupational and Environmental Health Scientists, comments on the possibility of a second ring of Kuiper Belt objects beyond the known one. If this is confirmed, he says, it would be a major discovery. The primordial solar nebula was much larger than previously thought, and this may have implications for studying the planetary formation process in our solar system. Dr. Wes Fraser of the National Research Council of Canada, a co-investigator on the New Horizons mission science team and the study's lead author, explains our solar system's Kuiper Belt long appeared to be very small in comparison with many other planetary systems, but our results suggest that the idea might just have arisen due to observational bias, he adds. So mainly, if this result is confirmed, our Kuiper Belt isn't all that small and unusual after all, compared to those around other stars. Our search for life in the universe is hindered by the fact that we have only one confirmed example of a planet where life arose, that is Earth, in our own solar system. With only one example, we can't determine which idiosyncrasies were important for the appearance of life and which were irrelevant. So anything we do to rule out the possible prerequisite moves us closer to finding the true prerequisites for life. If it is confirmed that the solar system formed from a solar nebula that was much larger and therefore much less unusual than we thought, it not only eliminates a small parent nebula from the list of possible prerequisites, it greatly increases the possibilities of finding another planetary system that meets all the true prerequisites for life, thus increasing the possibility of finding alien life. New Horizons principal investigator Dr. Alan Stern says this groundbreaking discovery revealing something unexpected, new and exciting in the distant reaches of the solar system, this discovery probably would not have been possible without the world-class capabilities of the Subaru telescope. The number and distribution of objects at the end of the solar system is a question for future study. But at the very least, the Subaru telescope's results indicate that new discoveries await in what was thought to be a very old, empty, boring void beyond the known Kuiper Belt.
Astronomy Daily, the podcast. Astronomy, space and science.
Space-based telescopes are remarkable, and future space telescopes could very well be made from thin membranes unrolled in space to enormous sizes. Their view isn't obscured by the weather in our atmosphere, so they can capture incredibly detailed images of the heavens. Unfortunately, they are quite limited in mirror size. As amazing as the James Webb Space Telescope is, its primary mirror is only 6.5 metres in diameter. Even then, the mirror had to have foldable components to fit into the launch rocket. In contrast, the extremely large telescope, currently under construction in northern Chile, will have a mirror of more than 39 metres across. If only we could launch such a large mirror into space. A new study looks at how that might actually be done. As the study points out, when it comes to telescope mirrors, all you really need is a reflective surface. It doesn't need to be coated onto a thick piece of glass, nor does it need a big, rigid support structure. What's really important is to hold the shape of the mirror against its own weight. As far as starlight is concerned, the shiny surface is all that matters. So why not use just a thin sheet of reflective material? You could just roll it up and put it on your launch vehicle. We could, for example, easily launch a 40-metre roll of aluminium foil into space. Of course, things aren't quite that simple. You would still need to unroll your membrane telescope back into its proper shape. You would also need a detector to focus upon the image upon, and you need a way to keep that detector in the correct alignment with the broadsheet mirror. In principle, you could do that with a thin support structure which wouldn't add excessive bulk to your telescope, but even if we assume all of those engineering problems could be solved, you'd still have a problem. Even in the vacuum of space, the shape of such a thin mirror would deform over time. Solving this problem is the main focus of this new paper. Once launched into space and unfurled, the membrane mirror wouldn't deform significantly, but to capture sharp images, the mirror would have to maintain focus on the order of visible light. When the Hubble was launched, its mirror shape was off by less than the thickness of a human hair, and it took correcting lenses and an entire shuttle mission to fix it. Any shifts on that scale would render our membrane telescope useless, so the authors took a well-used trick of astronomers known as adaptive optics. This technique, adaptive optics, is used on large ground-based telescopes as a way to correct for atmospheric distortion. Actuators behind the mirror distort the mirror's shape in real time to counteract the twinkles of the atmosphere. Essentially, it makes the shape of the mirror imperfect to account for our imperfect view of the sky. A similar trick could be used for a membrane telescope, but if we had to launch a complex actuator system for the mirror, we might as well go back to launching rigid telescopes. But what if we simply used laser projection instead? By shining a laser projection into the mirror, we could alter its shape through radiative recoil. Since it's simply a thin membrane, the shape would be significant enough to create optical corrections, and it would be modified in real time to maintain the mirror's focus. The authors have called this technique radiative adaptive optics, and through a series of lab experiments have demonstrated that it could work. Doing this in deep space is much more complicated, of course, than doing it in the lab, but the work shows the approach is worth exploring. Perhaps in the coming decades we might build an entire array of such telescopes which will allow us to see details in the distant heavens that we can now only just imagine. Well, that's another episode done and space dusted for another Monday. I hope you enjoyed our little adventure through space, space science and astronomy today.
Some interesting stories from the Astronomy Daily newsletter again today.
Yeah, we never know what's going to turn up. We'll be watching out for those meteors though this month. The Orionids were a bit of a fizzer from where I was last month, but I'm hoping the Taurids are going to be a spectacular display.
Meteors are always something to watch out for, and I know they are one of your favorite things.
Oh yeah, meteors for sure.
Along with robots, moon buggies, the Oort cloud, and asteroids and...
Yeah, just a few of my favourite things there. Thank you. How about we say goodnight, Hallie?
Okay.
See you all next week for Astronomy Daily.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
No, Hallie, we cannot make our own giant unrolling space telescope with tin foil. Put it back in the kitchen.
Righty.